So today I'm going to show you how to run evals on agentic applications using Arize Phoenix. Arize Phoenix is an open source system for evaluating GenAI applications, including LLMs, RAG-bots, and AI agents. They support multiple frameworks: Gemini, Claude, MCP, OpenAI, and LangGraph, so you're not locked into one single stack. Plus, it's actually pretty cool. Let's check it out. Okay, so before we start diving into the notebook, it's important to understand the agentic architecture that we'll be using for the evals in this video. I created a React agent that has access to Tavily Web Search, Wikipedia Search, and Current Datetime information. The agent is powered by LangGraph. It utilizes Claude 3.7 Sonnet for reasoning and Tavily for web search. It has multiple tools at its disposal, including Wikipedia Search for historical facts and current datetime information. The evals which we'll be conducting today are agent function calling, how well an agent selects a tool to use, extracting the right parameters from the user query, and generating the tool call code. Agent path convergence, how efficiently the agent executes multiple steps in a path to get an answer or a resolution. And Q&A on retrieval, whether a question was correctly answered by the system based on the retrieved data, in contrast to retrieval evals. Okay, so now we're in the notebook. Note, this isn't going to be a live coding video. The purpose of this video is a tutorial of the Phoenix platform to show AI product managers how they can use it to log their evals. All of the examples have already been run and instrumented in Phoenix. Okay, so now I'm going to scroll down to the bottom of the imports. And open up the Phoenix application. Note that it's running locally, but it can easily be run on a server. Note in the cell right below how I registered my project using the LangChain instrumenter as my trace provider. Okay, so let's open this up. Okay, so now I'm in Phoenix. I'm going to select my project on the left. All right, and this takes me to my traces. Traces are end-to-end journeys of requests through your AI system, covering everything from the original user query, to agent reasoning, tool calls, all the way to the final response. In LangGraph, these are instrumented via chains. Here's an example of a complete chain. Okay, I'm going to scroll down to Chat Anthropic because it's a little bit easier to see the entire trace history. Okay, so here you can see my system prompt, as well as the user query, and then the assistant response, where it decides to search based on the user query. So it calls the Tavily search tool in order to evaluate the best methods to evaluate large language models. No pun intended. Okay, so now I'm going to exit out of this. Hey, I'm Will. I'm an AI product career coach, and I've helped dozens of folks break into top tech companies. Data doesn't lie. PM job openings are up 54% from 2023 lows, and AI PMs earn a 35% salary premium compared to traditional PMs. AI product management is absolutely exploding right now. Ready to break into AI product management? DM me. It's open enrollment. Okay, so now I'm back in the notebook. Here's how I set up my agent. Okay, so I initialize the model using the Anthropic API key, and for the purpose of this, I'm using Claude 3.7 Sonnet with thinking enabled, and interleaved thinking enabled for better tool use and reasoning. I also instrumented a 5-minute timeout. All right, here I define my tools with the Tavily API key and the web search tool, create Tavily web search tool via Tavily. Here I have my current get current datetime tool. All right, so the purpose of this again is when the agent needs current information for web search, think of queries like, what's the weather like today, right? It can use this tool to get the current datetime and then pass that over to Tavily, okay? And this avoids using the model's training cutoff date. All right, and then we have a Wikipedia tool for historical fact information. So it's interesting when we pass user queries to the model to see whether it utilizes the search tool or the Wikipedia tool based on whether it's historical information being requested or current information. All right, and then we have the prompt template. All right, so notice how it has specific instructions for searching for current facts, news, or information that needs up-to-date sources. Search the web. For Wikipedia, search Wikipedia for the user's query and summarize the results. Use it for historical information, definitions, established concepts, and biographies. And then all the way on the bottom for time-sensitive queries, the current date, right? Always get the current date first using the get current date function before making search queries. Okay. All right, so we initialize the tools, and then we create the React agent. All right, we have a checkpointer for memory, and then I also included a mermaid diagram creating LangGraph agents, right, to just create a visual of the flow, right? So start, you can kind of think of this as a user query or when goes to the agent, and the agent kind of reasons through the question that's being asked, and it decides whether it'll use tools, right? Or it'll just end with a simple response, right? Tools get rerouted back to the agent, and then again, it can call tools recursively, or it can just end with a response. All right, so I set up this function to visualize, right, the streams that are coming out of the agent response. So it provides more high-level observability, right, into the agent's reasoning, as well as the tool calls, and then it will output the streams kind of as they come through. So let me show you an example of this. Here we have our initial test set. What's the weather like in Queens? Who is the king of the ancient Greek gods? And what's the best method to evaluate an LLM? All right, so here's an example of where we pass the first query. What's the weather like in Queens today? All right, so you can see the agent's reasoning. Hey, it's asking about the weather. This is a time-sensitive query. I should first get the current date and time, right? And then search for weather information in Queens, likely Queens, New York. Notice I didn't even tell it Queens, New York. It kind of just reasoned and assumed that. So pretty interesting. And then it created a plan. I'll get the current daytime using the function, and then I'll search for it, right? So pass the current information to the search tool, all right? So this is its reasoning. And then here, it's actually streaming through its response, right? So this would go usually like back to the user if there was a UI. And then it's going to make the first tool call here using get current datetime. It returns the date. Then it's going to search for the current weather in Queens using Tavily. And this is what the Tavily tool returned, right? Directly from the weather API. Okay, awesome. And then basically, there's a bunch more streams, but to sum it up, it's returning the current weather forecast back to the user. Okay, so here we have our two other queries. Look, for the sake of time, I'm going to skip over them because we'll actually be able to see and evaluate, right, the results when we start downloading the span data from the Phoenix server. So recall, right, if a trace is the end-to-end journey, right, through the agent, then a span is the individual operations within a trace. So think LLM call, that's a span, right? Tool execution, that's a span. The retrieval step, that's also span. Okay, so spans are the individual operations.